Ionic bonding. Ionic bonds form between a metal and a non-metal. The metal loses electrons to become a positive ion, and the non-metal gains those electrons to become a negative ion. The more electrons you have, the more negative you are, and the less electrons you have, the more positive you are. The two oppositely charged ions then attract in a giant ionic lattice. Ionic compounds have high melting points, and they only conduct electricity when they're molten or dissolved in water. Molten is when you melt them, because that is when the ions are free to move. When asked why ionic compounds do not conduct as solids, the marking point is the ions are not free to move. Saying they have no electrons is wrong. Covalent bonding. Covalent bonds form between nonmetals by sharing pairs of electrons. Simple molecules like water and carbon dioxide have low melting points and do not conduct electricity. Giant covalent structures like diamond, graphite, and silicon dioxide have huge networks of atoms and very high melting points. Graphite is special. It conducts electricity because each carbon has a delocalized electron, so an electron that is free to react elsewhere. A question that is often asked is, compare diamond and graphite. The structure point is the same, 4 bonds in diamond, 3 bonds plus a delocalized electron in graphite. The property point follows next. Diamond is hard and does not conduct. Graphite is soft and does conduct. Carbon allotropes. Carbon forms several structures called allotropes. Diamond has each carbon bonded to 4 others, making it the hardest natural material. Graphite has each carbon bonded to 3 others in layers that slide, with 1 delocalized electron per atom, so it conducts. Graphene is a single layer of graphite, strong and conductive. Fullerenes are hollow carbon shapes, including Buckminster fullerene, which has 60 carbons in a ball. Nanotubes are cylinders of graphene. Spec names you must know are diamond, graphite, graphene, fullerenes, Buckminster fullerene, and nanotubes. Examiners can ask about any of them. It's the same carbon, different shape, different job. Metallic bonding. In a metal, positive ions sit in a regular lattice surrounded by a sea of delocalized electrons. Those electrons are free to move, which is why metals conduct both electricity and heat. The layers of ions can slide past each other, so metals are malleable. Alloys are mixtures of a metal with other elements. The different sized atoms disrupt the layers, which is why alloys are harder than pure metals. To explain why metals conduct, always use the phrase sea of delocalized electrons, free to move and carry charge. That exact wording will secure the mark. Picture ions as floating balls in a sea of electrons. The sea conducts, the layers slide. This gives you both properties in one image. States and particle arrangement. In a solid, particles vibrate in fixed positions. In a liquid, they're close together, but they can move past each other. In a gas, they're far apart and move freely in all different directions. As you heat a substance, you give the particles more energy, so they break free of those fixed or closed positions and are able to change state. State changes do not change the particles themselves, only their arrangement and movement. Mass is conserved when you melt or boil.